We think we had wormholes figured out on paper. So Einstein's general theory of relativity, which is our understanding of how gravity works in the universe, says that any presence of mass or energy will warp the fabric of space and time. And so you can think to yourself, imagine warping space and time in such a way that you can cut a portal from your location in space and emerge in another location in space. So these wormholes, which we can describe on paper, we don't really know how to make them. And if we did know how to make them, we wouldn't know how to keep them open. Equations show that they are unstable. You might step inside and then it would collapse down on top of you, and who knows whether that's a good thing or not. It's probably not. In Interstellar, they went into black holes and through wormholes with high confidence that they would survive. But that's where the storytelling kicks in and the physics ends. I mean, it's science fiction. So a black hole is a region of space within which light doesn't come out. Nothing comes out. If you fall in, you don't come out. But it's a hole in the three-dimensional fabric of space. So it means you can fall in from any direction. Normally when we think of a hole, like you remove a manhole cover and there's a hole in the street. You fall through the hole, you come out the other side, and you can look and see where you came out. If there's a hole in space, you fall in from any direction, you end up in another place. And if that hole connects to another place, then you have a wormhole combining the two places that you might have fallen in. And you get a black hole by a very extreme high concentration of matter. And when you have that high concentration, the gravity right in the vicinity of that continues to go up and up and up. Then it reaches this threshold where light does not escape. That's when you would call it a black hole. The sun will never be a black hole, but there's stars in the night sky that we can identify that when they die and they run out of energy to hold themselves up, the thermonuclear fusion in their core ends, and the total gravity of all the material of that star overcomes everything else that would otherwise sustain it. And it collapses down to a singularity, a black hole. So you want to avoid black holes? Really? At all cost.